Physics Penguin.
Hello and welcome to Physics Penguin's Guide to Moments. Today we'll be finding out what moments are and how to calculate them. In the next video we will look at how moments get used in simple machines. A moment is created when a force is used to turn something. A moment can be either clockwise or anti-clockwise, but it isn't just a force. This picture shows a spanner being used to tighten a nut. The moment is the turning force, capital M, but it depends upon two other factors. The force from the hand, that's F, and also the distance, D, from that force to the centre of the turn, which we call the pivot or fulcrum. If this hand just tried to tighten the nut without the spanner, just by using its fingers, it would really not get all that far. But if the hand uses the long handle with the same force, that will provide much more turning force or moment. You need to be able to calculate turning forces. Now luckily this isn't too tricky. This is the formula. M equals F times D. Capital M stands for moment. Be careful because small m is always mass. Capital F is force applied, and small d is the distance to the pivot. The units are quite simple. Force is always measured in newtons, that's just capital N. D is measured in meters, small m. And moment is measured in newton meters, capital N, small m. This sounds like the measuring device for a force, the Newton meter, but it is spelled differently. Let's have a look at this seesaw. If the little penguin wants to balance the stupid walrus, then he needs to balance the moment or turning force. The penguin has much less weight than the walrus, but if he moves nearer to the end of the seesaw, he can get the biggest possible moment. On the other side, the walrus needs to reduce the distance between his centre of mass and the pivot. If he gets close to the middle of the seesaw, he should be able to balance with the tiny penguin. Ah, bless. Moments are very useful because a weaker force can be used to balance or even overcome a larger one using a pivot and a lever. This is so useful that Archimedes, the ancient Greek philosopher, once said, "Give me a lever long enough and a fulcrum on which to place it, and I shall move the world." So what's the big deal? Well, take a look at humans. They don't have the most powerful claws or jaws. They don't run all that fast, but humans are probably the most successful species on the planet. How have they achieved this? Humans are one of the few species that use tools. Tools often use moments to make a person faster or much harder hitting and stronger. A bicycle uses moments to make a person much quicker, while still using the same muscles and forces as just running around. A slingshot makes a human able to throw a stone much faster than by hand, making it go further and cause more damage. A can opener can allow any person to rip metal apart using the strength of their hands. Penguins don't actually have hands, so we have to rely on our superior telekinetic powers. Anyway, let's recap on moments. The moment is a turning force. You need to apply a force a distance away from the pivot, and if you multiply the force by the distance, you get the moment. Take a look at this thing. The elbow is a pivot, also called a fulcrum. The bicep muscle, that's the big one at the top of your arm, is pulling the lower arm up, and the weight of whatever the hand is holding is pulling down. Notice that the distance between the muscle and the elbow is very small. It connects almost at the elbow. This is bad for lifting. If we connected the muscle to the wrist, the arm would be much stronger. However, the muscle only moves a tiny amount, a few centimetres at most, but the hand needs to move a lot. The arm is designed to use moments to turn a little bit of movement into a lot, but it's not really designed for a lot of strength. Next week we'll look at this in detail, but for now we just need to spot the pivot, the force and the distance to the pivot. Well, I think it's time for you to check out what you understand and what you don't. Download the worksheet and give it a go. Pause the video, then I'll go over it when you've finished. Pause the video now. Language is really important here. Let's use the key words we met earlier. We can balance a seesaw if the heavy object is near to the pivot or fulcrum and the lighter object is further away. For example, if the heavy object is 5 times heavier, then the light object has to be 5 times further away. Question 2 is about the parts of a door handle and labelling them as a type of lever. In the diagram below, the pivot is A. This is always the part that everything else turns around. The applied force will be wherever the hand is placed. If the hand is further away, like position C, you'll get a bigger moment than if the same force was placed at position B, which is a bit closer. Question 3 is a table question. Remember that the moment equals the force times the distance from the pivot. So in line 1, force times distance is 5 times 0.4, which is 2.0 or just 2 Newton meters. That's capital N, small m if you want the short unit. In line 2, we need force. Well, force is the moment divided by the distance. 9 divided by 3 equals 3 newtons because it's a force. In line 3, we want distance. Distance will be the moment divided by the force. Now, the numbers aren't quite so nice here, but that's 8.76 divided by 7.3. You probably need a calculator, but it works out as exactly 1.2 meters, small m. Finally, in line 4, we want the moment again. So moment equals force times distance. 3.6 times 2.5 equals exactly 9 Newton meters, capital N, small m. Well done for trying that. Feel free to go back over any bits that feel a bit tricky. We'll be going into more detail on moments next week, so why not subscribe to stay informed of that. Until then, this is Physics Penguin saying ta-ta.